Hi, hello everyone. Hope you all are doing well. This is the 9th video of Azure AI Fundamentals Certification course. And in this video, we'll be discussing about generative AI solutions offered by Azure. In the previous video, we discussed about responsible AI principles. And here, we'll be discussing about generative AI and about Azure OpenAI. We'll be discussing about various OpenAI models and we'll be deploying some of them. The idea for this lesson is inspired from the AI-102 training I attended to pass the certification. I'll provide the link to the above said training in the description box below. Without further introduction, let's get into the video. Now, what is generative AI? Generative AI refers to a class of AI models that can generate contents like text, image, code, etc. So normally what we do is we give a natural language input, and in return, the model will provide us with various formats of output like natural language, image, or code. The LLMs use natural language processing techniques to process and generate human-like text. Some examples of generative AI models are Microsoft Copilot, ChatGPT, GENAI, and DeepSeek. So it is a wide umbrella term where we use AI models to generate content. That is what is generative AI is. Now, GitHub Copilot, which is powered by OpenAI, it is used to generate code. ChatGPT, as we all know, it is a large language model and is used for natural language processing and to generate human-like text. So those are examples for generative AI. Now, what is Azure OpenAI? So it is an artificial intelligence service that allows users like us to create and deploy AI models within Microsoft Azure platform. So we can deploy models in the Azure platform, play with it, fine-tune it, upload our own data to the model, train it, and we can deploy it. Now we'll go through few AI models which commonly appear in exam questions. One is the GPT models. So there is GPT-4 model, which is the latest generation model, and it is for generating natural language and for code completions. Then there is GPT 3.5, again for natural language processing, and it can do code completions. Then GPT 35 turbo model for chat-based interactions. So whenever you say GPT model, it is related to natural language processing and chat-based interactions. Now there is embedding model. So embedding model, what it does is it converts text into numeric vectors, and it is mostly used to compare text or compare documents. So what it means is these models convert everything into numbers, and similar items like similar words will have similar vector representation. So when we search for a particular word, it is very easy to retrieve anything related to that. So that is what is embedding model is. So wherever you see converting text into numeric vectors or for semantic similarity or something related to similarity, you have to go with embeddings model. Now there is DALL-E. DALL-E is to generate image from text. Then there is Whisper model, which is used to convert speech to text. Then there are text to speech models, which is used to convert text to speech. So these are the models which you need to remember. GPT model, it's for chat completions, code generation, natural language. Then embedding is for finding out similarities or converting text into numeric vectors. DALL-E is for generating image. Whisper is to convert speech to text. Now let us see a demo where we'll create an Azure OpenAI resource. Now I'm in my Azure portal. I have Azure OpenAI here. Now I will create OpenAI resource. Select your subscription. This is my resource group. I'll go with the default region, standard tier, and everything else I'll go with default. Now my deployment is success, and I'll go to the resource. So this is the OpenAI resource I have deployed. Now we can go to the Foundry portal. So I'll click here and it will take me to the Azure AI Foundry portal. So here we are in Azure AI Foundry, Azure OpenAI portal. And what will we do next is we'll deploy a model. So for that, I'll create a deployment. And here you can see various models present, various chat models present. So you can choose any one of this. So for the time being, I'll select GPT 4.1 mini model and then I'll confirm and I'll go with the default setting and I'll deploy the model. So now the model is deployed. So the model be deployed as GPT 4.1 mini, and here you can see give the model instruction and context. So here you can set the system message. So now what is system message? So the system message will set conditions for the language model. So we are telling the model or giving instruction to the model that you are a helpful assistant that responds in a cheerful, friendly manner. So all the output given by the model will be based on that system message. So we are setting the overall context for the model. We are telling the model for every answer you should behave like this. So that is what is system message. Setting a general context or style for the model. So this can be anything. You can say you are a press writer. Give the response accordingly. Or you are a poem writer. Or you are a helpful story writer. Like that, based on the system message, we can set the overall context for that model. So that is what is system message. Now coming back to the Foundry portal, here I'm just going with you are an just a basic system message and I will apply changes. So here you can provide any system message based on your use case scenario. Now here there is a chat playground where you can try chat with the model. So I'll just ask a basic question. So it has given me the reply. So it is just the GPT 4.1 model. So whatever we type here is called the prompt. So prompt is the way of telling the application or the model what we want it to do. That is prompt. Now, based how accurate our prompt is, the output will be better. So by formatting the style of our prompt, we can get better output. So that is what is known as prompt engineering. How to improve the prompt so that we'll get desired output from the model. For example, let us go back to the OpenAI portal and here I can ask what is GENAI to the model. So that is the prompt. Now the model has given a paragraph, then some other details. So now I'm asking the model, what is GENAI? Give me bulleted points as answer. I don't want paragraph. I just want points. So I'm being more specific in my prompt. So let us see the reply from the model. So the answer is more precise and short. Has given me just the points. So that is what is prompt engineering. We are being more clear with our prompt, so the output will be more accurate. So now I can ask a mathematical problem. What is 9 into 2 plus 8? So that is my prompt. So it has given me the answer. The answer is 26. Now I'm asking the same question. What is 9 into 2 plus 8? Give me step-by-step calculation. So that is a more specific and clear prompt. So now let us see the reply. So it is giving me step-by-step calculation. So like that, you can be more accurate with your prompt so that the output will be in the format that you desire. So that is what is known as prompt engineering. So prompt engineering is the process of prompt improvement. So we can improve the quality of response from the Gen AI by considering prompt engineering. And here I have to mention few prompt engineering techniques. These techniques appear in the options of questions. So I just want to touch upon the prompt techniques. So some of them are few shot learning, priming, break the task down, chain of thought output. Now let us go into the Microsoft documentation and see what each of these are. So these are prompt engineering techniques. There are a lot of them. We'll go through some important ones. One is few shot learning. So in this, we are teaching the model in a prompt. So we are telling the model that I will ask like this and you will give the reply in this format. And I have given 2 examples. Now the model has to give me the output in this format. That is what is few shot learning. We are teaching the model in a prompt itself. We are giving a set of training examples in the prompt, and we are providing an additional context to the model. So that is what is few shot learning. The model is learning from the prompt. We are giving a set of training examples to the model in the prompt. Now next is priming the output. So this we have seen that we are including few words of phrase at the end of the prompt to get the desired form of output. So we are asking the model that, so this is the question and provide me the answer like bulleted list of key points. So that is prime the output. Now there is chain of thought prompting. So this is breaking the task down technique. We are asking the model to proceed step by step and present all the steps involved. So here is an example. So who won the most gold medals in the Olympic Games? And we are asking the model to take step-by-step approach in your response. So it is showing each steps and what it did in each step. So that is what is chain of thought prompting. So if you're doing a complicated math problem or if you're generating a code, we can ask chain of thought prompting. Show me the steps. Show me your thought process. So that is one of the prompt engineering technique. Now there are others like affordances, queue, etc. But I just wanted to mention the most important one, which normally appear in the options of questions. So that is what is prompt techniques. Now next is fine-tuning parameters. So back to the Azure portal. Here you can see two options. One is add your data. So here you can add your data source and the model can refer to it and provide answers. So if I'm asking the model who is John Smith and what is his role in the company Condoso. So let us see the reply. So the model is telling, I don't have specific information about this individual. So you have to provide me some context or details about the company or individual. Then only I can provide you with the correct reply. That's where we have to add our own data for our specific use cases. You can add our data source and later the model can go through the data source and provide us proper information. So here you can select a data source. It can be from Azure AI Search, Blob Storage, Cosmos DB, Elasticsearch, or from a web address, or you can directly upload files so that the model can get more accurate information. So next are the fine-tuning parameters. So these are some of the fine-tuning parameters. So what is fine-tuning? So fine-tuning is the technique of making the model more apt for our use case. So we can tweak any of these parameters and adjust the model in the way we want. So these are the fine-tuning parameters. So we can adjust this. So pass messages included. If we increase this, there will be more context for the model. The model will remember our previous chat. You can increase or decrease this. Then there is maximum completion token. So how much token output the model can provide. So now there is a question, what is a token? You can consider token as characters in the text. Like 4 characters is 1 token. So by adjusting this token, you can limit the output from the model. So if I go with these many tokens, then the output from the model will be long. We'll get a lengthier output. Based on the amount of the token, the cost incurred will also increase. So you can adjust the token based on the requirement. Now next is temperature. So it will control the randomness of the response. Use lower to be more deterministic. Again, keep in mind what is the feature of the temperature parameter. If the temperature is low, the model will be more deterministic. And if the temperature is high, the model will be more creative. So if I want to write a poem or if I want to write a story, make the temperature high. So the model will be more creative. Or if you want accurate cut dry answers decrease the temperature. So the model will be more deterministic. Now here there is top P. Top P is similar to temperature. Again, it will control the text diversity by selecting the most probable words until a set probability is reached. So when top P is high, the model will be more creative. When top P is less, the model will be more deterministic. Then there is frequency penalty. It will reduce the chance of repeating a token. That is what is frequency penalty. Based on how often it has appeared in the text, it will decrease the likelihood of repeating the exact same text. Then there is presence penalty, where we can reduce the chance of repeating any token that has appeared in the text. This will increase the likelihood of introducing new topping in a response. So with frequency penalty, we can adjust the appearance of same words from the output of the model. If we reduce frequency penalty, same words will appear more and more. If we increase the frequency penalty, it will find different words. Now, presence penalty is to introduce new ideas to the output of the model. So if we increase the presence penalty, it will encourage the model to give new concepts and new ideas. So based on your use case, you can adjust these fine-tuning parameters. So first, we'll try adjusting temperature. So I'll reduce the temperature. I want the model to be less creative. And I will slightly reduce top P as well. And then I'll ask the model to write a short story. So the model has given a short story. So now what I'll do is I'll increase the temperature. So I want the model to be more creative. And again, I'm asking the model to write a short story. So we can see the difference between the output. So now I couldn't see much difference. So I increased top P as well. Then ask the model to write a short story. So here, when the temperature and top P is high, you can see that in a bustling city lived a boy. Every day he filled his sketchbook with fantastical creatures and colorful landscapes and all those descriptions. And when temperature was less, I think the story is more dry. But there is not much difference as such. But I can see here it is a little bit dry and here it is described in a poetic manner. So anyway, you can try adjusting these parameters and see how the output differs. So these are the fine-tuning parameters where you can adjust the output from the model in your desired manner. Now we have deployed a GPT model. We did chat with it. We set the system message. Then we saw how we can add data to our model. Then all the fine-tuning parameters and what each of these parameters is supposed to do. Now let us get back into the slide. Before that, I would recommend you to delete the model and the Azure AI resource if you're following along. Now back to the slides. We have seen fine-tuning parameters. We know what temperature is. It will control the randomness of the model. If we lower the temperature, the model will produce more repetitive and deterministic response. And increasing the temperature means more creative response. Then there is tokens. We can set a limit to the number of tokens a model can respond. Now one token is roughly 4 characters for typical English text. Now there is stop sequence. Make responses stop at a desired point, such as the end of a sentence or list. Specify up to 4 sequences where the model will stop generating further tokens in a response. So that is stop sequence. Then there is top P, which is similar to temperature. We can control the randomness of the model. If we lower the top P, the model will be more deterministic, and to make the model more creative, we have to increase the top P. Then there is frequency penalty. It will reduce the chance of repeating a token based on how often it has appeared in the text. Then there is presence penalty, which will reduce the chance of repeating any token that has appeared in the text at all so far. And for presence penalty, we can increase the presence penalty if we want to introduce new topics in our response. So these are the fine-tuning parameters. Now next is knowledge test. Which parameters should you configure to produce a more diverse range of tokens in the response from a chat solution that uses the Azure OpenAI GPT 3.5 model? Pause the video, come up with the answer, and resume the video. So for more diverse range of tokens, we should go with presence penalty. We have to increase the presence penalty parameter. Now to the next question. You have built a conversational AI using Azure Openai Studio. Make the chatbot's response more deterministic and less creative. Which two parameters should we adjust? So for making the response more deterministic and less creative, we have to tweak the temperature and top P parameter. Now, you need to build an app in Azure to compare documents based on semantic similarity and generate numeric vectors representing document tokens with minimal development effort. Which Azure OpenAI model should you use? Now, once you see semantic similarity or any kind of similarity or numeric vectors and they're asking which OpenAI model should you choose, you have to go straight for the embeddings model. If the question is related to natural language or chat completion or something like that, you have to go with any of the GPT models. If the question has generating image from text, then you have to go with DALL-E model. So just look for those keywords. Then what should you do to ensure that an Azure OpenAI model generates accurate responses that include recent events? So one is modify system message. We know what is system message. It is setting the context for our model. So that wouldn't help to include accurate and most recent events. So we can exclude that. Then we know what is few shot learning. It is a prompt engineering technique and we have seen that. Then again add training data. So again we have seen that we can add training data to the model. It can be file from search resource, blob storage, etc. Now what is add grounding data? So what it does is it will help the model to generate more accurate responses based on the recent events. So we can tell the model if it's not able to find out the correct answer, it can go out to external resources and find the correct answer. So if you are asking about a most recent event, the model is not trained with that data. So the model doesn't have the information about that recent event. So if you are asking what is the weather today, the model is unaware of that. So by allowing grounding, the model can go out, search from external resource and provide the most accurate response. So you might have heard about RAG or retrieval augmented generation, which helps the model with grounding data. So here the correct answer is for including recent events in the model's response. The correct answer is option B, add grounding data. In this lesson, we saw various OpenAI models like GPT, DALL-E and embedding models. Also, we deployed a GPT model in Azure AI Foundry. We fine-tuned the model and tested the model in Chat Playground. In the next video, we'll be discussing about Azure AI Foundry. Thanks for watching the video and I'll see you in the next.